Have you ever said the words, "but it works on my machine"? If you have, then you are in exactly the right place. You've probably heard the name Docker thrown around a lot. I mean, it's a technology that has completely changed the game for how we build, ship, and run our software. So today, we're going to break it all down: what it is, why it's so important, and how you can start using it the right way.
It really all begins with this one infamous phrase. Seriously, every developer has said it, and every operations person has heard it a million times. This single sentence, it just perfectly captures the frustrating core problem that Docker was built to solve once and for all. It's the sound of inconsistency, of late nights, and just a ton of headaches.
And look, this isn't just some small annoyance, it's a huge roadblock. When your software works one way on your laptop, but then behaves completely differently in testing, or worse, in production, well, that kills collaboration and causes massive delays. We call this the developer's dilemma, and for a long time, it was just this constant source of friction in getting software out the door.
So what's the fix? Well, think about this for a second. Think about how standardized cargo containers totally revolutionized the shipping industry. Before them, loading a ship was just chaos. It was this custom job, a crazy game of Tetris with boxes and barrels of all shapes and sizes, which led to stuff getting broken and wasted space. But after, everything just fits. Docker did the exact same thing, but for software. It created a standard, universal package.
In that standard package, it's called a container. This is the key idea right here. A container bundles everything an application needs to run. All the code, the libraries, the configuration files, the whole shebang, into one single isolated package. And because of that, the software runs the exact same way no matter where you put it. Now you might be thinking, hold on, isn't that just a virtual machine? And that's a fair question, but they're actually very different. Here's the core distinction. A VM needs a full-blown guest operating system for every single app. That makes it heavy and really slow to start up. It's like building a whole separate house with its own foundation for every single app. Containers, on the other hand, are incredibly lightweight. Why? Because they all share the host machine's OS kernel. It's more like building different rooms on top of one solid foundation. This makes them way faster, way more efficient, and you can run a lot more of them on a single server. So how do you actually use this in practice? Well, the workflow is actually beautiful in its simplicity. You start with something called a Docker file. Think of this as your blueprint. It's just a text file with step-by-step instructions. From that blueprint, you build an image, which is basically a read-only template of your application. And finally, you run that image to create a container, the actual, living, running instance of your app. So it's blueprint, template, running app. It's this simple process that guarantees your app will work the same everywhere. Okay, so we've got the concept, we've got the workflow. Now let's talk about the real payoff. Why did this idea completely take over the software world? Let's dive into the actual advantages this brings to you, your team, and your projects. It really all boils down to 5 huge benefits that you get when you adopt this container-first approach. These are the real game changers that have made Docker an absolutely essential tool for modern development. First and foremost, consistent performance. That whole "it works on my machine" problem, it's just gone, because the environment is identical everywhere, from your laptop to the production servers. This directly leads to way fewer bugs and much higher quality software. And for teams, onboarding is an absolute dream. I mean, imagine a new developer joins. Instead of wasting days or even a week setting up their machine, they can be up and running with a perfect replica of the production environment in a matter of minutes. Now, that consistency also unlocks 2 other massive benefits: portability and scalability. An app that's packaged in a Docker container can run anywhere that Docker is installed. Your laptop, a server in your office, AWS, Google Cloud, you name it. You are not locked into any single provider. And then, when your app gets super popular and you need to handle more traffic, you just spin up more identical containers. It's practically built to scale on demand. Okay, so these benefits are obviously powerful, but to really get them, you have to use the tool correctly, right? Just because you're using containers doesn't automatically mean they're efficient or secure. So let's go over some of the most common mistakes and how to avoid them. Think of these as pro tips. First up, don't create bloated containers. It is so tempting to start with a big, familiar base image, like Ubuntu, but that just adds hundreds of megabytes of stuff you don't need, and it increases your security risk. The solution is simple. Always start with the smallest possible image. A popular one is Alpine, which is this tiny, minimalist Linux. You can even go for what are called distroless images, which have literally nothing but your app and its direct dependencies. Keep it lean. Next up is a huge security mistake that a lot of people make. By default, processes running inside a container run as the all-powerful root user. Now, if an attacker were to compromise your app, this could give them the keys to the kingdom and let them do some serious damage. The fix is absolutely essential. Just use the user instruction in your Docker file to create and switch to a non-root user. It is such a simple change, and it dramatically improves your security. And please, oh please, never, ever hard code secrets like API keys or passwords directly into your Docker file. When you do that, you are literally embedding them into your image, making them visible to anyone who can get their hands on it. It's a massive security flaw. Instead, use secure methods like Docker's own secrets management system, or pass them in securely as environment variables when you run the container.
So when you put all of this together, the standard packaging, the awesome benefits, the smart best practices, what does it all add up to? Let's zoom out for a second and see where Docker really fits into the bigger picture of how we deliver software today. Docker is, without a doubt, the engine that powers modern continuous integration and continuous delivery, or CI/CD. Because containers create a predictable, consistent environment every single time, they are the perfect tool for automating the entire pipeline of building your code, testing it, and deploying it. For so many companies, this has meant cutting deployment times from hours of stressful manual work to just minutes of automated, reliable releases. This is how modern teams ship better software faster. Which brings us right back to where we started, with that shipping analogy. In today's world, you would never ship valuable goods across the ocean without a standard container, right? It's just the safest, most efficient, most reliable way to do it. So, the question I'll leave you with is this. In a world of complex software, is your code still traveling without one? If the answer is yes, now is the time to change that. Your team and your code will definitely thank you for it.